Okay, here we have a question on angles, and, well, it's on trapeziums. You've got an isosceles trapezium drawn here. These two lines here tell us that these two sides are the same, and that's why it's an isosceles trapezium, because it's got two sides the same. The other things we know about trapeziums are the opposite sides are parallel, and that allows us to work out this angle x, which is the first question. Work out the value of x. Because these lines are parallel, we're going to use the rules for a line crossing parallel lines. Now, there's one rule that is where you have alternate angles, one side, one the other, where two lines cross. That gives us equal angles. Another rule is where we have corresponding angles, where one line crosses two parallel lines, where these two angles are the same as well. And the one that we need to use for this question is the one to do with allied or interior or supplementary angles, and that's that they add up to 180 degrees. So those two in there are 180 degrees. So we're told that we want to find x. So we've got 75 plus x is 180. So x must be 105 degrees. Second part of this question, we're asked to work out the area of trapezium. This is the one formula we are actually given on the higher exam paper for two-dimensional shapes, and that formula is the two parallel sides, if we call this A and B, A plus B times by the perpendicular height, which is the height between them, in this case 7.5, and then we half that. Now the half can be written in all sorts of ways. Sometimes it's written on the front, sometimes we have like a half h, A plus B, or A plus B over 2h, all sorts of things, ways of doing this formula. But essentially we add the two parallel sides, times by the height, and then half it. So we add the two parallel sides is 10 plus 14, which is 24, times by 7.5, I think it's 180, and then yep, 180, and then we need to halve it, so we do 180 divided by 2, which is 90. So we have an area of 90 centimeters squared.